Dear students, welcome back to the e-learning course 4, Derivatives and Risk Management. In lesson 3, you will get some insights into swaps and risk management. After a short introduction into the nature of swaps, we will study how the hedging of interest rate risk works. Finally, we provide an example of how commodity prices can be hedged by using futures. The learning goal of session 3.1 is twofold. First, we examine how swaps are used in financial risk management, and second, we study how they are valued. A swap is an agreement between two companies to exchange cash flows in the future. The agreement defines the dates when the cash flows are to be paid and the way in which they are to be calculated. Usually, the calculation of the cash flows involves the future value of an interest rate, an exchange rate, or other market variable. Our discussion of swaps in this lesson centers on two popular swaps: interest rate swaps and fixed for fixed currency swaps. The most common type of swap is an interest rate swap. With this swap, a company agrees to pay cash flows equal to interest at the predetermined fixed rate on a notional principal for a number of years. In return, it receives interest at the floating rate on the same notional principal for the same period of time. Consider a hypothetical swap between Microsoft and Intel. Suppose Intel agrees to pay to Microsoft an interest rate of 5% per annum on a notional principal of, say, $100 million. And in return, Microsoft agrees to pay Intel the 6 months LIBOR on the same notional principal. In this example, Intel is the fixed rate payer and Microsoft is the floating rate payer. Another popular type of swap is known as currency swap. In its simplest form, this involves exchanging principal and interest rate payments in one currency for principal and interest rate payments in another. For better understanding, suppose a hypothetical currency swap agreement between IBM and BP. Suppose that IBM pays a fixed rate of interest of 5% in sterling and receives a fixed rate of interest of 6% in dollars from BP. This is termed a fixed for fixed currency swap because the interest rate in both currencies is fixed. Note that initially the principal amount flows in the opposite direction to the arrows in the figure, while the interest rate payments during the life of the swap and the final principal payment flow in the same direction as the arrows. So far, we have a basic understanding of how swaps work. The next step is to get familiar with how these swaps can be valued. For that purpose, we take another look at interest rate swaps. Recall that a fixed for floating interest rate swap requires fixed interest payments for floating rate payments where the floating rate is the LIBOR rate. From the perspective of a floating rate payer, a swap can be regarded as a long position in a fixed rate bond and a short position in a floating rate bond, so that the value of the swap, denoted as V swap, is simply the difference between the two bond values. The value of the fixed rate bond B fixed can be determined by using standard bond valuation techniques as described in our e-learning course 3 about fixed income analysis. The value of the bond is simply the present value of all the cash flows that will be received by the owner of the bond. In our notation, C is the fixed payment and L is the notional principal. Sometimes bond investors use the same discount rate for all the cash flows underlying a bond. But a more accurate approach is to use a different spot rate for each cash flow. In our example, the spot rates are denoted as RI, where I goes from 1 to N. To value the floating rate bond, we note that the bond is worth the notional principal immediately after an interest rate payment. In order to understand this, we have to dig a little deeper. You might recall from our previous discussion that the floating side of a swap is a bond that pays LIBOR. Since the bond's cash flows are as well discounted at that particular rate, we have a scenario where the coupon rate equals the discount rate. In this context, it follows that after each interest rate payment, the bond is equal to its face value L. However, immediately prior to the interest payment K star, which is known at the beginning of the period, the bond is worth L plus K star. Knowing this, we can discount back to the present using the continuously compounded risk-free LIBOR rate R star. It might be the case that the evaluation principle based on fixed and floating rate bonds might seem a little bit complicated on first sight. However, let me assure you it's not. In order to convince you, let us look at a specific example. Suppose a financial institution has agreed to pay 6 months LIBOR and receive 4% per annum on a notional principal of $100 million US. This means the financial institution is long on the fixed side and short of the floating side. The swap has a remaining life of 15 months. The LIBOR rates with continuous compounding for 3 months, 9 months, and 15 months maturities are 2.6%, 2.8%, and 3.2% respectively. The 6-month LIBOR at last payment was 2.7% per annum. The fixed rate bond has cash flows of $2 million on the first payment date, $2 million on the second payment date, and $102 million on the third payment date. Discounting these cash flows with the corresponding discount factors yields a value of the fixed rate bond of $101.946 million. The floating rate bond produces a cash flow of $101.35 million in 3 months, consisting of the principal of $100 million and interest rate payments of $1.35 million based on the 6 months LIBOR. The present value of the 3 months cash flow of the floating rate bond is then $100.6934 million. The valuation of the swap is now straightforward and requires only to compute the difference between the value of the fixed rate bond and the value of the floating rate bond. Doing this with the corresponding numbers implies that the swap value is $1.2526 million. Next, we take a closer look at how currency swaps are valued. For that purpose, we'll look at fixed for fixed currency swaps, which involve exchanging principal and interest rate payments in one currency for principal and interest rates payments in another. Currency swaps can be valued in terms of bond prices as well. The dollar value of an outstanding swap, where dollars are received and foreign currency is paid, can be expressed as follows. In this context, BD is the value of the bond defined by the domestic cash flows on the swap. BF is the value measured in foreign currency of the bond defined by the foreign cash flows on the swap. To convert these foreign currency denominated cash flows into dollar cash flows, we need to multiply the value of the foreign bond by the corresponding spot exchange rate S0. Note that the spot exchange rate is expressed as numbers of dollars per unit of foreign currency. For the sake of completeness, the value of a swap where foreign currency is received and US dollar is paid is just the opposite and written as. Let us now illustrate the evaluation of a currency swap by means of an example. Suppose a financial institution has entered into a currency swap in which it receives 5% per annum on yen and pays 8% per annum in dollars. In this example, we assume that the swap will last for another 3 years. The term structure of LIBOR interest rates is flat in both Japan and the United States. The Japanese rate is assumed to be 4% per annum, and the US rate is 9% per annum, both with continuous compounding. Principal values in the two currencies are $10 million US and 1,200 million Japanese yen. The current exchange rate is $1 costs 110 yen, which implies the current spot exchange rate as 0 is 1 divided by 110. The present value of the Japanese cash flow is 1,230.55 million yen, while the present value of the US dollar cash flow is $9.6439 million. To determine the value of the swap, we multiply the foreign bond value with the spot exchange rate and subtract the value of the domestic bond. According to this definition, it follows that the value of the swap is $1.543 million. After having carefully studied session 3.1, please start with the review questions.